This is linear relationship part 2. So let's look at our number routine. I'm going to go to the next screen because there are more space on the next screen. The temperature outside is 85 degrees. It increases 2 degrees in temperature every hour. Complete this table and write an equation. So that means in 0 hour, it is a starting temperature of 85 degrees. In 1 hour later, the temperature increases by 2 to the starting value temperature of 85, so now it's 87. In hour 2, it increases another 2 degrees to the starting value of 85, so that's 89. And in hour 3, it increases another 2 degrees from the 4 degrees to 85, and that would be 91 degrees. How can I write an equation from this? Well, y equal. What is the rate of change here? How is it changing by? It is changing by 2 degrees every hour. So the rate of change is 2 degrees every hour. And do we know how many hours are? No. So it's 2x plus a starting temperature of 85. And that is our equation. To check your work, 2 degrees, it changes 2 degrees for 3 hours. That's 6 plus 85 is 91. So, number 1, for this problem, we will count the number of squares in each figure, complete the table, write an equation, and complete the graph. So as you can tell, in the first figure number, there's 1 square. In the second figure number, we had 1, and then it seemed like they added 2 more, so now it's 3. In the third one, it seemed like we had a 3, then they added 2 more to the arm, so now there's 5. In the fourth one, we seemed like we had 5, then they added 2 more arms, so it is 7. So what is the equation here? How can we find the equation from here? So when you're given a table like this, and straight up like the table like this one, how can you find the equation from it? Well, let's look at the rate of change. What is the square increasing by? It is changing by 2 plus 2 for every one figure number. So and do we know what figure number to stop at? Not really. So it'll be 2x. But what is the initial value is the question. So let's see. If we multiply this by 2, 2 times 2 is 4. How do I get to a 3? I take 1 away. 2 times to the figure number of 3, that'll be 6. Then I take away 1, that'll be 5. And the next one is 2 times the figure number 4, take away 1, it is 7. So 2x minus 1. Y equals 2x minus 1. So let's graph this. Figure number 1, 1 number squared. Figure number 2, 3 squares. Figure number 3, 5 squared. Figure number 4, 7 squares. So in here, which one is the dependent independent? The dependent would be to find a number of squares. It depends on which figure number you're looking at. So the dependent would be number of squares. Independent would be that one. Let's see what this says right here. Using square tiles, what will be the fifth tile? Oh, so it'll be 2 times 5 is 10 minus 1 is 9. So the figure number 5 would have to have 9 squares. So let's draw that if you would like to. Start with this one, and then 1, 2, 3, 4. 1, 2, 3, 4. Then it adds 2 more to the end, and that's 9. All right, next one. Find the outside perimeter of each figure in the sequence. All sides of these triangles measure the same. We will call the measurement of each side 1 unit. Complete the table, write an equation, and complete the graph. In figure number 1, I see a perimeter of 1, 2, 3. In figure number 2, I see a perimeter of 1, 2, 3, 4. In figure number 3, I see a perimeter of 1, 2, 3, 4, 5. In figure number 4, I see a perimeter of 1, 2, 3, 4, 5, 6. So what is our equation? Just think about it. So we started with one figure number. We have 3. And we added another triangle to it. But as you can see, the perimeter only went up by 1. Then we added another triangle, and the perimeter only went up 1. So what is the rate of change? It is changing by 1 for every one figure number. So y equal changing, and do we know which figure number to stop at? No, so it's 1x. And then is that just the formula? Just 1x. Y equal 1x. Let's see. If I multiply the 1 by 2, I get 2. What do I need to do to get the 4? Plus 2 more. So that must be the starting initial value. So 1 times 3 is 3, plus 2 is 5. 1 times 4 is 4. What do I need to get to 6? Plus 2 more. So the equation is y equal 1x plus 2, or y, more simpler way of writing, y equal x plus 2. Oh, this is an additive relationship. How do you turn a 4 to 6? Plus 2. A 3 to 5? Plus 2. A 2 to 4? Plus 2. And 1, 2, 3? Plus 2. Let's graph this. Figure number 1 is a perimeter of 3. 2 is a 4. 3 is a 5. A 4 is a 6. So what would 0 be? 0 plus 2 would be 2 right there. Someone has used toothpicks to create a pattern. Use a number of toothpicks to create a table and a graph. Write the equation that will help us find the number of toothpicks in any figure in this sequence. In figure number 1, I see they use 1, 2, 3 toothpicks. In figure number 2, they use 1, 2, 3, 4, 5 toothpicks. In figure number 3, they use 1, 2, 3, 4, 5, 6, 7 toothpicks. So figure number 4 would probably be 8. No, figure number 4, if you had to guess, well, let's draw it. 1, 2, 3, 4. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. So is the number toothpick increasing by 2 for every figure number I draw? Yes. So plus 2, plus 2, plus 2. So, and this is for every one figure number. So the rate of change is 2x. That means it's changing by 2. So what is the initial starting value? So if I multiply this by 2, multiply this by 2, multiply this by 2, multiply this by 2, that's 8. Plus 1 more is 9. 3 times 2 is 6, plus 1 more is 7. 2 times 2 is 4, plus 1 more is 5. 1 times 2 is 2, plus 1. So the equation is y equal 2x plus 1. What if I had to figure out figure number 5? 2 times 5 is 10, plus 1 more. I would need 11 toothpicks. So let's graph this. 1 figure number, I need 3 toothpicks. 2, I need 5. 3, I need 7. 4, I need 9. 5, I think I said 11 because the rate of change is increased by 2. So number 4. Ooh, now you're given the graph. Can you make a table from it? So now, and then make an equation. Ooh. Well, let's see. From here, it seems 0 to 4. 1 to 5. 2 to 6. 3 to 7, and 4 to 8. So what is the relationship between the x and the y? How do you turn a 0 to 4? A 1 to 5, a 2 to 6, 3 to 7, 48. I think that's additive. I think you just add 4. Can't be that easy. 0 plus 4, 1 plus 4, plus 4, plus 4, plus 4. The relationship is just plus 4. You add 4 to x. Another way to do it is this. What is the rate of change? It is increasing by 1 for every x value. So it's 1 of the x value plus 4 is 5. 1 of this x value plus 4 is 6. 1 of this x value thing. So it's y equal 1 of the x value plus 4, or y equal x plus 4. Next one, complete the table. If I substitute the x's, or replace the x's with one of these values, what would the y be? So 4 groups of negative 2 is negative 8. Take 10 away, negative 10. 4 groups of negative 1 is negative 4. Take 2 away, be negative 6. 4 groups of 0 is 0. Take away 2 is negative 2. 4 groups of 1 is 4. Take away 2 is 2. 4 groups of 2 is 8. Take away 2 is 6. 4 groups of 3 is 12. Minus 2 is 10. And that is it. So our last thing is activity is called Guess My Equation. You're going to be given a table. Can you guess the equation from it? I'll give you a hint. It's going to be y equals something. So, how do you turn a 0 to a 1? A 1 to a 3, a 2 to a 5, a 3 to a 7, a 4 to 9. Well, let's look at a hint. What is the rate of change? How is it changing by? It is changing by 2. 2 for every one x value. So it's changing by 2 for every x value. So it's changing by 2 for every x value. So 2 times 1 is 2. Then what do I need to add to that to get 3? Plus 1 more. Doesn't really work. Let's see. 2, the rate of change is 2 for every input. So 2, the input is 2, is 4, plus 1 more. It's changing, the rate of change is changing 2 for every input. That's 3, plus 1 more. So y equals 2x plus 1. Let's see if that is correct. Yes. Next one. What do you think the equation is for this one? Well, for this one, negative 4 to 4. I'm going to skip that one. I'm going to go to the positive number. This is increase. The rate of change, it looks like is increasing for 8 for every input. So it's going up 8 for every input. So it's going up 8 for the input of 1. That's 8. How do you get a 4? Take 4 away. Let's see. The rate of change is 8 for every input. If you have 2, that'd be 16. Take away 4 is 12. If it's changing 8 for every input of 3 is 24, take away 4. I think it's y equal 8x minus 4. Yes. And our last one, what do you think the equation from this table is? Let's see. This is the rate of change is from 4 to 1 is minus 3. 1 to negative 2, 1 be 1 above, 2 below 0. That's negative 3. Negative 3. So it's changing by negative 3 for every input, every one input. So if negative 3 times 1 is negative 3, how would it get to 1? I'm going to go to 0 first. Negative 3 times 0 is 0. How do you get the 4? Plus 4? Negative 3 times 1 is negative 3. Plus 4 is 1. Yeah, it is. You have 3 negatives. If you add 4 positive, it's positive 1. Negative 3 times the input of 2 will be negative 6. If I add 4, it's negative 2. So I think it's y equal negative 3x plus 4. And it is. So can you create an equation from a table?